So welcome level 1 physicists, and today we're looking at measurements in physics because measurements are critical to the subject. So the first thing we're going to look at is the idea of a dimension. Okay, so basically in our subject, a dimension is the type of quantity being measured. So for example, force is measured in newtons, but the type of quantity is force. Okay, time is measured in seconds, but the dimension is time. And for example, mass would be a dimension, which of course is measured in kilograms. So as an example, here we have the car driver's age. Is it recorded in years? But the time to do 1 kilometer lap would be recorded in seconds. But the dimension would be the time dimension. Okay, so in terms of measurements, every physicist in the world uses the same units and symbols for each dimension. Okay, so these are the standard dimensions that every physicist knows, and the other units and symbols are derived from these dimensions here. Okay, so for the dimension of length, we use meter. For time, it's in seconds. Mass is in kilograms. Current is in amperes, and temperature is in Kelvin. Okay, so you have to know that the units of each of these dimensions and also the symbols. Because when you're writing answers, you need to write those down because every value has to have a number and a symbol. So we're going to be using numbers of different sizes. So rather than writing down, for example, 1 hexameter as a number with 1 and 18 zeros, rather than writing those 18 zeros down, we use the superscript E in front of our meter to say that we've got 10 to the 18 meters. Okay, and the same for all of these values here, which you have to memorize both the prefix, which is the letter, and also the number that's related to that prefix. Okay, so for level 1, I'd expect you to be able to memorize from 10 to the negative 12 all the way to 10 to the 12. Okay, you have to be able to rote learn those scientific notation values, both the number, what the number represents, and the prefix. So how do you convert these metric prefixes? There's 4 steps. So you've got to be able to basically determine the units that you know and the units you want to find out. Okay, then you write the relationship between the two and write an equation as a fraction equaling 1, and finally multiply the known by this fraction to get the unknown prefix, okay, or value. So what does this look like? So looking at measuring human hair, so a human hair is about 50 micrometers in diameter. To express that in meters, so we know that we've got 50 micrometers, and we need to convert that into meters. That's our unknown. So we write the equation using the values that we have from this table here. Okay, which you've now memorized the table. And so therefore 10 to the negative 6 meters divided by 1 micrometer. Okay, but you have 50 micrometers, so we're going to multiply that fraction. So it'll be basically 50 times 1 times 10 to the negative 6, which equals 5 times 10 to the negative 5 meters, or 50 times 10 to the negative 6 meters. Okay, those are both acceptable at level 1. Okay, so you have to be able to do those conversions. Another important principle in physics is the idea of accuracy versus precision. In common English language, we tend to use them interchangeably, but in physics, they have specific definitions. Okay, so accuracy is basically how close your value that you've measured is close to the actual value, whereas precision is how close your values are together. So what we really want is high precision and high accuracy. So as you see from the 4 examples there of trying to hit the bullseye, we want high accuracy and high precision, which is the first example. So not only are our values close together, they're close to the actual value. If we have low accuracy but high precision, the values are close together, but they're nowhere near the bullseye, nowhere near the value we want. If we have high accuracy and low precision, it means that we're kind of close in terms of our values to the value we want, but they're quite spread out. And low accuracy and low precision, though you have neither. Okay, so you have to have an understanding of those values now in level 1 physics, or those concepts. You also have to have an idea around significant figures. Okay, so that's how we basically in physics define how precise a measurement is. Okay, so the more significant figures, the more precise it is. Okay, and significant figures are basically the number of values which we know, and the last value is the uncertain value. So that's basically the more value numbers you have, the more precise your value is. And we have the concept of leading zeros, which you see there in blue. The non-digits, or the zeros, the numbers which are non-zeros, the zeros between the non-zero digits, which are the yellow one there, and we've got trailing zeros. So what do those concepts mean? Well, it's basically to work out significant figures, you have to use those concepts this way. Okay, so all non-zero digits are going to be significant. Okay, so you've got to consider all the non-zero digits. Zeros between non-zero digits are significant. Zeros in front of your non-zero digits are not significant. Okay, zeros at the end are significant of your values, and zeros at the end of the number, but to the left of a decimal, are not significant, but they are important placeholders. Okay, so those are the 1, 2, 3, 4, 5 rules that you need to consider. In level 1, the central point is that any value that you get for your exam answer in level 1 physics should have the same number of significant figures as the variable in your question with the smallest number of significant figures, because otherwise that means your answer is more precise than the equipment you're using, which is an impossibility. Okay, so the example I've given here is 273.1. Okay, they're all non-zero digits, so that's all significant. That's 4 significant figures times 0.15. So the first zero is not significant. Okay, it's a leading zero, so only 2 significant figures. So even though you get, on your calculator you get 40.965, the answer, when rounded to the correct number of significant figures, is 41. Okay, because 0.15 is only 2 significant figures, so therefore the answer can only be in 2 significant figures.